In section 10.2, we're going to be looking at the uses of measurements of central tendency and measurements of dispersion. So when we talk about measurements of dispersion, we're talking about how spread out is the data, how disperse is it. The range would be a matter of looking at over what range of numbers does the data exist. So what's the lowest number? What's the highest number? And we talk about mean absolute deviation. We're talking about how different is each individual measurement from the average. That's kind of what we're looking at with those items. Now, when we talk about measurements of central tendency, in statistics, when we talk about the average, we call it the mean. Okay, and it's abbreviated by X with a bar over the top, which you read as X bar. And if we want to find the data set, we're just finding the average. We add the observations together and we divide by the number of observations. The median is the centralmost value when you put the numbers in numerical order, and that can only be, there can only be a centralmost number when they're in order if and only if there's an odd number. If there's an even number of values, then you find the average or the mean of the two middle values. And the mode of a data set is the value that occurs most frequently. There could be one mode, two modes, three modes, or no mode. So the number of modes is not limited to a finite number, nor does there even have to be one. Okay, so if we look at calculating these values, if I want to find the mean, the median, and mode of this data set, to find the mean, I'm going to add them all together. 9 plus 10 is 19. Plus 12 is 31, plus 15 is 46, plus 16 is 62, and there are 1, 2, 3, 4, 5 of them. Okay, so what we would want to do at that point is go ahead and do the division and find the mean. So 62 divided by 5 equals 12.4. And that is my mean. They're already put into order for me, so the centralmost value, the median, is 12. And you'll see that each item occurs only one time, so there is no mode. No single value occurs more than any other. Okay, if we want to take a look at this other data set, I'm going to go ahead and use a calculator to add these together, or actually I can show you some other ways to go about it. 15 and 15 is 30, 16 and 14 is 30, 14 and 14 is 28, 18 and 15 is 33. So I've got 30, 60, 93 plus 28 is 121. So for my mean, X bar is equal to 121 over 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. So 121 divided by 8 equals 15.125. Okay, that's 15.125. If I want to find the median, I have to put them in order. And you can see that right now they're not in order. So I'm going to put them in order. 14, 14, 14. Then I have 3 15s. Then I have a 16 and an 18. Let's make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8, it's not an odd number. So the middle two would be numbers 4 and 5. 1, 2, 3, 4, and 5. And it's easy to find the average of those two because the average of 15 and 15 is 15. And when we talk about the mode, I have two different values that occur 3 times. The mode is 14 and also 15. So this would be called a bimodal data set because it has two modes. So these are measurements of central tendency. When we look at measurements of dispersion, we have the range, which is the difference between the largest and the smallest value, right? The difference between the greatest value and the least value. And we have mean absolute deviation, which is different than standard deviation, which is a phrase you may have heard before. This is a different measurement. Mean absolute deviation involves taking every observation, finding how different it is from the mean, adding them up, and dividing by the number of observations. So we're finding the average difference from the average. That's what we're finding here. Okay, so let's go through how we go about doing this. Okay, if I want to find the range, first I want to put these things in order. You'll notice that's kind of helpful. So I have 111, then 115, then 120, then 130, then 135, and then 145. Okay, so these are now in order. So if I want to now work on the range, it's going to be 145 minus 111. So my range here is 34. So all of my data exists between 111 and 145. So in this set of 34 numbers is where my data exists. Now if I want to find the mean absolute deviation, first I have to find the mean. So let's do that. So I have 111 plus 115 plus 120 plus 130 plus 135 plus 145. That's 756, and there are 1, 2, 3, 4, 5, 6 items. So if I divide by 6, my mean is 126. Okay, so x bar equals 126. And what I want to find here now is I want to find the difference of all of these different values. What I'm going to do is find the absolute value of 111 minus 126 plus the absolute value of 115 minus 126 plus, actually, I'm going to need to move some of this stuff out of the way. I guess I should move the 145 with it, and let's move this. So I have plenty of room. Plus the absolute value of 120 minus 126 plus the absolute value of 130 minus 126 plus 135. Sorry, I still am going to run out of room. 126 plus the absolute value of 145 minus 126. And all this will be over, it's a great line, will all be over 1, 2, 3, 4, 5, 6. Right? So 111 minus 126, the difference is 15, right? The absolute value is negative 15, but the absolute value is 15. And in this case, it's 11. And here it's 6. And now it's 4. And 135 minus 126 is 9. And 145 minus 126 is 19. All divided by 6. I've got 6 different items. So 6 plus 4 is 10. 11 plus 9 is 20. And 15 and 19 are 34. So that's going to be 10, 30, 64. 64 divided by 6. And 10.66667. So basically it's 10 and 2/3. Right, is my absolute deviation. Okay, so what we've worked through is how to find the mean, the median, the mode, the range, and the mean absolute deviation. So not standard deviation, which is a more common measurement to learn how to measure.